next step in this process is going to be to add a little more complexity to our single cactus segment. And that complexity is going to be the ability to specify a tilt value for the top of the segment and the bottom of the segment independently. And the tilt will be what it sounds like, tilting the vertices in that part of the segment around a particular axis, tilt axis. But before we do that, I'd like to have a little more real estate to play with. So I'm going to go to the Window menu, click New Window, maximize it, and then change it over to the Geometry Nodes editor. So now we have more space to work with, which I find is easier when you have a large number of nodes. So let's first change our inputs. So in the panel on the right, we'll go over to the Group tab, and we're no longer going to specify a direction. Instead, we're going to specify a tilt value and a tilt axis. So the tilt axis is a vector, and the direction is a vector. So instead of deleting one and then re-adding it, we'll just rename direction to tilt axis. And then we're going to specify two more inputs, which is the start tilt value and the end tilt value. And again, the start refers to the tilt for the bottom part of the segment, and the end refers to the tilt of the top part. So let's choose the length, which is a floating point value, and make 2 copies of it. We'll rename the first copy start tilt, and the second copy end tilt. For consistency, let's also rename radius to start radius, since it's the radius at the start of our segment. Alright, let's press N and collapse that panel. And now that we have a tilt value and a tilt axis, we can sort of replace direction with something that we compute from those 2 inputs. So basically what we're going to do is take a vector that points straight up, and we're going to tilt it using our tilt value, and that'll be the new direction. So we don't need this normalize anymore. We can delete that. Let's create that vector that points upward. So we're going to add a vector node. Let's actually rename it to up, and we'll make sure it has a length of 1 by just giving it this value 0, 0, and 1. So that's a vector pointing straight up. We want to rotate that vector. We want to tilt it. And so for that, there is a node called vector rotate. And by default, it is rotating by a particular angle around a particular axis. It's exactly what we want. So the vector we want to rotate is the one that points up. The center can remain at 0, 0, 0. The axis that we want to rotate around is our tilt axis, and the angle that we want to rotate is our start tilt. So the output from this node is now our replacement for what used to be direction. So we can plug that in where direction used to go, down here at scale. Now our position vertex nodes, we have one for positioning the vertices at the bottom of the segment, and we have one for positioning the vertices at the top of the segment. There's more information that those nodes need now. Specifically, they need to know what the tilt axis is, and they also need to know what the tilt angle is. So let's plumb those values through so they can reach these nodes. So for the first one, we want just the start tilt. So I will just, again, make a little forking branch here, bring that over, and I'm going to label that start tilt. The other value we need is the tilt axis itself. So I'll do the same thing here. I'll clean this up later. For now, I'll leave it messy. And let's give this a label, tilt axis. Okay, and let's do this one more time with tilt axis and bring it over here for the second node. And the second node also needs the tilt value, but it's not start tilt, it's end tilt. So let's drag that out, create a reroute node, bring it over here, and rename it as end tilt. Let's modify our position vertex node group so that it can take in these two new values. So select either of the two, hit tab to get into the editing mode, push N to pull up that panel on the right, and actually one of these inputs is misnamed where it says new vertex position. That should really be new center. So let's fix that. And we're going to have a new input called the tilt axis. Let's put it up at the top. So let's take vertex position, make a clone of it, and then use the arrows to push it up to the top. And let's call it tilt axis. Next, let's add a new input at the bottom, and we'll call it the tilt. So let's simply go to the bottom, hit the plus value, change it from a vector to a float, and we'll call it tilt. We can press N to close the panel. So the scale and add nodes are going to remain, but we need a bit of space between them. And here's what we're going to do. We're going to bring in a vector rotate node. And what we're going to do is we're going to take the value coming out of the scale node and plug that into the vector that's being rotated. The axis that we're rotating around is the tilt axis. The center can remain as 0, 0, 0, and the angle is the tilt angle. And the output of that is what should be added to the new center value. And this is our new node setup. So let's get back out to here and let's plug these new values in. So tilt axis into tilt axis, end tilt into tilt, and the same over here. Tilt axis into tilt axis, and this is also misnamed. This should be start tilt, pardon me, and let's plug that into tilt. Let's return to our main Blender window, and let's give this a tilt axis, because currently it's 0, 0, 1, which is a rotation around the vertical axis. That's not what we want. So set the Z component to 0, and let's tilt around the Y axis. So set the Y component to 1. And now you can see that if we modify start tilt, we are tilting the lower part of our segment. Notice that it also modifies the direction in which the segment moves upward, in which the segment is growing. And if we grab the end tilt, you can see that we're only modifying the top. So this is going to give us even more freedom to create a more sort of organic look for our cactus when we link a lot of these segments together. It's time again for another round of cleanup. Let's start linking up segments to create a larger structure. And let's begin by highlighting all the nodes except the input and output nodes and creating a new node group from that. Now in this node group, what we're going to do is have basically a one-to-one correspondence between inputs and outputs. And in this way, what we can have is the outputs from one of these nodes becoming the inputs to the next node in a chain. It's simply going to make the wiring a little more simple. Let's go ahead and create the outputs. So there's already a geometry output called geometry, but let's rename that to body, as in the body of the cactus. Let's create another one which is of type object, And let's call it xsect. And yes, it's the same xsect that we have as the input. Let's create another one of type vector, which is the tilt axis. Another one of type float, which is the length. Next is another float called end tilt. Another one called end radius. Another one, the shrink factor. Another one of type vector, which is the end center. And finally, another float called the tilt correction, which I'll explain soon. Now let's go to the inputs. And we have completely tossed away our geometry input that we had from the very beginning. Let's bring it back and keep it at the top. So its type is geometry, and let's call it body so far. Then we want to bring in the xsect. Well, the xsect is already here, but I want these in a particular order, so I'm just going to use the arrows to bring xsect up to the second position. For the third, we want the tilt axis. So bring that up. In fact, this is going to be easier to do if I zoom in. This is where I want tilt axis, followed by length. Length is missing. Okay, no problem. We are going to add it. After length, we want start tilt, followed by start radius, followed by shrink factor, which we have, start center, great, and then instead of end tilt, in fact, please delete end tilt, let's add one more new float, and we're going to call it tilt correction. So length is not actually missing. This is something you've got to look out for when you create nodes like this in Blender. So I'm going to delete the length input, and in fact it's the one named scale that was length all along. So let's just rename it to length, and I'm going to move it down to below tilt axis, like this. Great. I'm going to close the panel. Now the next thing I'm going to do is I'm going to set up these one-to-one links between the input and the output. And then do a little bit of rejigging, but not changing fundamentally any of the connections involved. Next, let's take the incoming body so far and add to it the new geometry that's generated here. So for that, we're going to need a join geometry node. And we're going to plug the new geometry that we've created up here into that node. And we're also going to plug in the geometry that was input. Now let's deal with this loose end here. This is the tilt value that we are plumbing into the second position vertex node. That's currently not connected to anything. And so what we're going to do is drag this down, and we're going to compute the second tilt value from the first, and we're going to use that tilt correction. So here's our tilt correction, and here is our start tilt right here. And this is very simple. So remember, the tilt is the angle away from perfectly vertical. And so all we're going to do is multiply that by the tilt correction. And the tilt correction is going to be a number slightly less than 1. And so what that means is that as we stack more and more segments onto our cactus, they will go from whatever tilt angle they are currently at to closer and closer to perfectly vertical. I'm not a botanist, but I'm going to say that's how these plants grow. So let's add a math node, and let's give it the multiply function. And we're going to multiply our start tilt by our tilt correction, and that's going to give us our end tilt. Now we're going to do something similar with the radius, because what's going to happen with the data flowing horizontally across here is whatever comes out as the output is the input for the next version of this node, for the next segment in the cactus. And so recall that the radius at the bottom of the segment starts at a particular value, and then the shrink factor reduces that radius. Well, that should be the new start radius of the next segment in the cactus. So let's find where we've computed end radius. Here it is. And let's bring it down. And let's plug it in as the output, where we currently have end radius, like that. And as usual, a little bit of cleaning up. In the same way that we want the radius value at the end of the segment to be the radius value used at the beginning of the next segment, we want to do the same with the tilt value. So we need to go and find where we've computed the end tilt, which is right here. And we need to plumb that through to the output as well. We also want the end center of one segment to be the start center of the next segment. So let's do that as well. So here's our start center. Here's where we're computing end center. And let's plug it in over here. Also, in the same way that we use the shrink factor to make the radius smaller as the cactus moves upward, or as we move from segment to segment, we want to do the same with our length value, and we haven't done that yet at all. So let's come over here, grab our length, grab our shrink factor, and multiply them to create the length for the next segment. I think we're finally ready to go multi-segment with this. So let's get out of this node group and back to our top level view. Let's give our new node group a name. Let's call it one segment, since it represents one segment of our cactus. Let's drag it over to be closer to the inputs. and we can see that we actually no longer need end tilt as an input. So let's kill end tilt. That's better. All right, so we're going to create, for now, only 8 segments of our cactus. At the end of the entire tutorial, we can create as many new segments as we want. For now, we'll stick to 8 because there will be some more rewiring that's going to happen. And if we have more than 8 segments, it's going to be a lot of rewiring. So we're going to do this by doubling a few times rather than rewiring 8 times or 7 times. So let's make a copy of our new node. In fact, let's not even worry about the output for now. Let's just cut that link. And then line up the outputs from one with the inputs of the other and link them all up. Then copy those two and repeat the process. And then repeat the process one more time. And at the end, let's take that final cactus body and make that the output of our geometry node system. Now let's go back to our main Blender window. Now we can see that we've got 8 segments of a cactus. You can see the effect that the shrink factor is having, making the top smaller than the bottom, but each segment lines up perfectly with the next, because we've always plumbed through the end tilt value to be the start value, or the start tilt value of the next segment. The same for the radius and any other relevant parameters like that. But this is sort of 8 separate objects. So let's weld them together into one object. So come back to our geometry node system and insert a merge by distance node. And the default distance will probably suffice. Let's see in a moment. I suspect everything is basically perfectly lined up, and so that default value should be a perfectly good threshold. There it is. And now we can play around with, for example, the start tilt value. If we tilt the cactus, we can see that it is only affecting the bottom. And the reason for that is our tilt correction. We haven't actually set that. Let's do that now. So we're going to come back down here, open up our inputs, go to the bottom, and add a new input. Make it a float value. Let's call it tilt correction, and plumb it through into that first node, that first segment's node. Let's go back to our main window, and let's create a tilt correction of, let's say, 0.8. Now let's tilt our cactus. That's better. So with each segment, we have a slight correction of the tilt toward perfectly vertical. This is going to be particularly useful when we have arms on our cactus that sprout sideways from the main branch or the main stem of the cactus. Without any particular special planning, they will automatically grow upward rather than straight outward. If we return to the geometry node setup again, one thing we can do is we can move that shade smooth node out of this section here. So let's do that. So it's called set shade smooth. Let's just delete it from here. Return to here, and let's just shade smooth the entire cactus all at once.